from blue to green. So, and then I put two nice examples, which look much nicer on the computer, I have to say. That would be the perfect tone and saturation for a red stone and a blue stone. We don't know what they are yet. Clarity. So again, we use the same terminology, but we don't use the same system. We don't grade color with the D to Z, but we grade the color and the components of the color, modifications of the color. Same for clarity. We don't say SI1, VS2, but we talk about transparency. So amount of light that can be transmitted through the stone. It's not like tone, it's different. In this case, we are talking about more inclusions means lower clarity, which means less transparent. So we have transparent stones. You can see through the stone. Maybe you can even almost read on the other side of the stone. Semi-transparent, which means the stone is transparent, but there are quite a lot of inclusions that are somehow interfering with the light. Then we have translucent. Translucent, imagine chalcedony, agate. So light is transmitted, but you cannot see through the stone. Semi-translucent, it's even less transmitted light. You will see only at the edges where the stone is very thin. You can see a little bit of light. Otherwise, you have an opaque stone. In this case, it's a lapis, or there's many examples. The stone will not pass through. If you see light passing through, it is not a lapis. That's the concept. Transparency is a tool or is an indication of identification of the stone. If a stone is supposed to be opaque, you cannot see light. Otherwise, it's another stone. Anyway, there is some similar stones to lapis, which are easily identified because there is a little bit of light that goes through the stone. So immediately you can say this is not lapis. Okay. Carat weight. Well, not much to say, is the weight of the stone. Same story as diamonds. 1 carat is 0.2 grams. This is a unit that we use. It's a weight unit for gemstones. We cannot use a bigger unit. We cannot use grams because we would talk about 0.00 something grams. So it's much easier to say 1 carat than say 0.2 grams. It determines somehow the rarity and the value of the stone, because a 10 carats, let's say amethyst, is a small stone, but a 10 carat ruby is a huge stone. So according to this, the carat weight can make quite a big difference on the price. The cut quality. There is no cut grade for gemstones. In a gemstone certificate, you will not find any grading of the quality of the cut. But because you are dealers, you buy stones and you sell stones, you know that when a stone is not well cut, somehow the value of the stone is reduced. This is a classic example of a very deep stone, and you don't want to pay for the pavilion, you want to pay for the crown.
Are the proportions similar to a diamond
Uh, no, I mean, it will never be mentioned on the certificate because there is no grading system, I have to say. Identification means the certificate says natural ruby. It's a ruby, that's it. And there is no, again, classification in terms of excellent cut, very good cut, or unless it's an exceptional stone with beautiful proportions, beautiful finish, and then the lab give you a extra letter or an extra certificate where it says the stone is one of the most beautiful that we have seen. But that's an extra that a lab can do for you for exceptional stones.
There's no standard.
No, no. If you think the quality of the cut, it would be almost impossible. Stones would be, most of them would be poor, fair, good, maybe, but
even with the right measurement, like even with the right measurement, let's say mostly it's like diamond. It's not like as you said, here, let's say to the polish. You cannot say this is not for the polish. You cannot say this is not for the version. You cannot say it's a polish.
we can say, but there is no system. I cannot put it on the certificate, natural ruby, and then polish is excellent, cut is. There is no. I mean, I can do, but that would be me or.
That depends on the appearance of the seller. So.
Yeah. Yes. There is excellent cut color stones. There are some dealers that are specialized in that, and they only sell that. But it is not a common practice. And yeah, at the moment, no, there is no system. Very simple.
Say, from a terminological point of view, is there an ideal cut for certain color stones? Like a diamond, you have to have a certain number of facets and angles and you get the best brilliance.
From diamonds, you want brilliance. From color stones, you want color.
Is there an ideal cut?
No. No.
If I may, if you cut the gemstone like you cut the diamond, excellent, would it be better?
Yes. Yes. You know, when we talk about, okay, when the stone is not well cut, you see a window. You know what the window is. You look through the stone and there is a hole. If you cut right, you need to close the pavilion with the right angles. Then you close the window, you have more light and more color, but you lose weight. If you want to deal with excellent cut, you can do it. You pay the cutter money, you waste material, and you sell excellent cut gemstones. But it's not required, and plus, remember, we can say this between us, you can afford to waste, almost, to waste diamond rough. You want the perfect cut, you do it. But when you have a ruby, you cannot waste anything because you have one ruby. The rarity of the color stones is so high, I'm not talking about quartz, but sapphire, rubies, emeralds, you cannot waste a single carat because you don't have another one.
Preservation of
Yeah, mostly preservation of the size. Yes. So you need to compromise. There will be a little window, or there will be, I don't know, a little bit higher crown, but you cannot. Well, you can, but you are wasting thousands of dollars because you want a ruby perfectly cut. I mean, you cannot do that. Rubies are not common. Sapphires are not common. Emeralds are not common. Instead of diamonds. Diamonds, you can. Yeah, completely.
example, in Tanzania we have pre-prism. So if you want the test cut, probably you cannot get the pre-prism.
Yeah, Depends, yes, okay. We are talking about cutting. The cutting means you have to orientate the rough gem. Some stones like tanzanite have three colors, three colors. So which color do you want? The violet or the blue? You want the blue, okay, but the stone is flat. If you want the blue, you need to cut 5 carats. And then you say, okay, I don't need the blue, maybe I get the bluish violet. Then you turn the stone and you get 8 carats. So that's why color stones cutting is very, very complicated. You need to respect the craft, you need to respect the color that will come out. That's why sapphires are often so deep, because they need to cut on the length of the crystal. So they trying to make it as long as possible. If they go on the other side, they will lose a lot of material. So I mean, for many reasons, but there is no grading system, but if you sell excellent cut gemstones, you are a specialist in excellent cut gemstones. Then you need to have a special type of customers, because majority of people they don't know, they will not pay more because you say the cut is good. They don't even understand the meaning of that most of the time. So. You know what is a crown, pavilion. Okay, so look at this stone. The market is 90% like this in color stones. Most of the stones are cut, faceted, but according to the best carat weight that you can get. We have an off-center culet, a non-perfectly oval shape. The girdle is up and down. Okay. So in going to the classification of all the stones, we classify according to group, species, and variety. When we say sapphire, we have to say few things before that. For instance, okay, group is 2 or more minerals. Remember, gemstones are minerals that have similar chemical composition, crystal structure, physical properties. So, for example, garnets. Garnets belong to the same group, so they have to be the same thing in terms of crystal structure, properties. But then we have each member of the group can have a small difference in terms of chemical formula. For instance, grossularite is one species of the group of the garnets. For a difference in the chemical formula. And then we have each member of the species could have a different color or could show a different phenomena. So that will be the variety. So we have garnets, we have grossularite, we have the green grossularite, it's called tsavorite. The orange grossularite is called essonite. Okay, so it's like you have a sauce. That's the group. Then you put garlic. Then it becomes a garlic sauce. And then you, I don't know, you change the color. It becomes something else. But the base is the same. And they have to be the same. Otherwise, how can we identify it? We need each mineral to belong to the same group with the same characteristics from everywhere. A garnet from Africa is the same as a garnet from Pakistan or from India. That's how we can identify it as a garnet.
is variety a function of physical property?
No. Variety is function of color or phenomena. Phenomena means cat's eye, change, color change. So it is the manifestation of a little difference inside.
Then here, corundum any species and would be completely correct.
Yes. So the blue corundum is called sapphire. The red corundum is called ruby. The group of corundum are oxides. See, in some type of minerals we start mentioning the group. So garnet, you know garnet. But if I say oxides, you don't know, because we start from the species.
So dementite, you have dementite
Demantoid is a variety of
of that.
garnet, of andradite garnet.
So garnet is a group and is dementite.
Yes,
But when it comes to the corundum, corundum is a species and sapphire is a group.
yes. Is that okay? Yes, so we do a certain steps, a sequence of steps to follow that will finally get to identify that gemstone. So first is the color, transparency, apparent hardness and toughness. I can already see if the stone is hard enough or if it's tough enough, if there is cleavage. I can see all that. Most of the time, maybe the stone is just being polished, so there is no scratch or there is no chips, so I cannot see the structure of the stone, but sometimes even internally you can see cleavage planes, so you already know where you have to go with the identification. And obviously it's a non-destructive test. I cannot scratch the stone to see if it's hard enough. I mean, you will kill me, I believe. But when it's a rough piece of stone, then I can scratch it, you will not notice. And I can see if it's a fluorite, it's a green, they come to the lab with green, beautiful green stones, fluorite. They think it's emerald, but especially if it's a rough stone, you can easily test and it scratches very easily. So, but in general, we cannot do any destructive tests, obviously. Or even use it acids. I cannot put a drop of acid and see, this is, I cannot do that. So it follows some physical and optical properties. So physical would be specific gravity, which is done with the hydrostatic scale. Hardness, toughness, we have already done. Otherwise, we proceed with the optical test, which is a refractive index, optic sign, pleochroism, or a spectrum. This, we are still in the field of basic gemology or basic gemological testing. So, use of optical, okay, I want to, so specific gravity. This is a good indication, especially when you are doubting between 2 or 3. You don't start from the specific gravity because it's not one of the most precise measurements that you can take. But when you are to doubt and you have to choose between 2 or 3, specific gravity can help. It is basically performed with the scale. We need to measure the stone in the air and in water, do a formula and find the specific gravity, which will be how many times the stone is heavier than water. So if I have a corundum which is 4, that means it's heavier than is 4 times heavier than water. So it's not the density; it's a specific gravity. Okay, probably the most important tool to identify a stone is the refractometer. What you see in the picture is the refractometer, the light source, and the liquid, contact liquid. So how does it work? We are going to, problem is this works only for faceted stones. So I need at least one polished facet. So I need to place a little bit of contact liquid on the refractometer because I need to exclude air, otherwise I will measure the air. And I put the stone on that small window, the small glass. The light source, obviously, from the back will illuminate. And this is something that I will see the scale. In this scale, I read 1.56. So according to that, I mean, there is a chart, and you will most of the time identify the stone. Each type of stone has a different refractive index. So it is very, very important. And of course, you have to do it in, precisely, I mean, otherwise you will get a different reading.
The scale is in what is the scale? How do you measure it? 1.2, 1.5?
You see the numbers?
Yeah, what is it? Is it the centimeter?
No. This is basically a measurement of how much slower is the light inside the stone compared to the air.
Nanometers or something?
No, it's not it's not a measurement. It's only a unit. It's a how many times. If you consider that light goes through the air, and that's 1. When it goes through a more dense material, of course it has to slow down. So we are measuring how much the material is slowing down the light, which means it is more dense than air. So 1.5 means the material is 1.5 slower. Sorry, is slowing down the light 1.5 times more than the air. So it is times, okay?
And each stone have different.
Huh?
And each stone have different.
Sorry, I didn't get you.
So each stone have different.
Yes, yes.
What's this unit scale called?
Refractive index. It's called refractive index. Of course, there is a formula, but we don't have to apply the formula. We have that scale, which has been. See, the refractometer itself, it's built according to a certain alignment. If you mess with the scale, you get another number. So it's been placed at the right place because the physical, the optical path of the reflection has to be correct. Then you get the right refractive index. So, for instance, ruby is 1.66, 1.76, 77. We will discuss this also. A beryl is 1.57. Okay, so the ruby is optically more dense than a beryl. That's the reason, but for me it's important if I read 1.76, okay, on that scale, here, this is a ruby, this is a emerald, or aquamarine. A blue topaz, 1.62. So if you're doubting, blue stone, what is it, aquamarine or topaz? Do a refractive index, simple, 162, blue topaz. So this is I think, and not only me, it is probably the most important tool to identify a gemstone. But you need a faceted surface, at least one polish. Yeah, you see, you put the stone on that glass. It needs to be in contact. Otherwise, you will not. All that light reflection with the specific critical angle, the mirror that goes to the scale, you need the reflection. Otherwise, it will not work. See, the principle is when you are in the sea and you see your feet are very close, that's refraction. Everything looks closer because there is the angle of the light changes, because from air to water it changes. From water to ruby it changes because it's more dense. So the light will travel slowly, slower. So we are basically going to measure how much slower the light is traveling through that stone. One more instrument is a very simple polariscope. All these are very simple instruments. There is nothing electronic. We are only looking at certain optical properties of that stone. A polariscope is made of two filters. The light is from the bottom. So you put the stone in between the filters and you will get informations about single or double refractive stones, pleochroism, double refractive obviously, and so the first point is single refractive and double refractive stones. Single refractive means that the light goes through the stone. Imagine one beam of light. When the light comes back, it is still one. So one. Double refractive means that the light goes through the stone, it doubles, it splits, and it comes back to us, doubled. If you know how to use a loupe, you can easily do it. You look through a glass or you look through a diamond, you will see everything very sharp. The diamond is single refractive. The edges, the culet, it's very, very sharp. If you do the same with tourmaline or a moissanite, you will see everything doubled. It looks like it's not, you cannot focus almost, but it's not you, it's the stone. It's doubling all the images. So with the polariscope, I can easily separate single refractive gemstones and double refractive gemstones. It's a very important test because, for instance, red stones, a red spinel, a ruby, or a red garnet, I can easily separate the ruby because the ruby is double refractive, the spinel is single refractive. So what I will see is, I will see the light and dark, that the stone which will look light and dark, it's according to my moving the stone between the filters. So, position 1, the stone is dark. I turn the stone is bright. Then again dark. We used to do it in 90 degrees steps. The fourth one, the light is dark again. This stone is double refractive. If it was single refractive, it would be like the number one, all the way. It will not go light, dark, light, dark. So now I know if the stone is single refractive or double refractive. I can check if there is pleochroism. Turning the filters, and putting the stone in between, I can see if the stone has a different color in different directions. So if I put the tanzanite in the polariscope, when I turn the stone, it will go from violet, blue, and grayish, yellowish. If it doesn't change the color, there is no pleochroism, which meaning is the stone is single refractive. Normally, double refractive stones have a pleochroism, even if it's very weak. That's the meaning itself of being double refractive, to different directions inside the crystal. Obviously, you cannot have a colorless stone pleochroic, because if it's colorless, there is no color, so you will not see any change of color, even if it's double refractive. So dichroic, trichroic, it means 2 colors or 3 colors. A sapphire is dichroic, a tanzanite is trichroic. It all starts from here. All the properties that we discuss are due to a crystal system, a crystal structure of that specific mineral. We have 6 crystal systems. Cubic, for instance, cubic, we have diamonds, we have garnets, we have spinel, tetragonal, hexagonal, trigonal, orthorhombic, monocline, and tricline. Sorry, it's 7 systems, not 6. For instance, beryl is hexagonal system. So we have aquamarine, emerald, heliodor, morganite. All these are beryls. Same crystal system. A much less friendly instrument is the spectroscope. It's not friendly at all because it's not easy to actually see what you want to see. The principle is simple. Again, we see from violet to red. That's the spectrum. When you put something in between, something means A mineral, it means some chemical, basically some chemical element, even some gas or whatever it is. It will absorb a certain wavelength, it will transmit a certain wavelength. The result is the color of the stone. When a ruby is red, because the red passes through, the other components are absorbed by the stone. So with the spectroscope, I will analyze, that's the scale, okay? All these colors are there on the scale. So what I want to see is, where are the black lines? Or where are the bright lines? These are emission lines or absorption lines, which have a meaning in terms of chromium is there or not, iron is there or not. So, and it's again, it's not that simple because it's a small instrument and then you need a chart to compare, but in some cases it can give a very good indication of what mineral it is, what type of stone. Can work with rough, the polariscope can work with rough. So yeah, refractometer, you need a facet. Polariscope, you don't need a facet. A spectroscope, you can work with rough. So each one has some plus and minus. Okay, two different principles for spectroscopes, prism or a diffraction rate, but that's not important. So all this, starting from the visual observation of the gem, which color is it? Is it transparent? Is it pleochroic? Is it, I can even feel the specific gravity of the stone. Or we'll use the scale, it's even better. All these tests, all these results combined together will take me to the identification of the gem. And we are still in the middle of the way. We are still at, okay, if this is a ruby, or this is a spinel. So sometimes my work is finished. If I identify an aquamarine, a blue topaz, a red spinel, a tanzanite, that's it. But the second part of the job would be for certain stones, if there is any treatment, if there is or no treatment, and if possible to determine the origin, the geographic origin. So modern techniques include the use of Raman spectrometer, UV smear, infrared spectrometers. For instance, even the picture is not that clear, I mean, there, but this is the spectrum of a natural spinel and a synthetic spinel, which I don't need the Raman to tell me if it's a synthetic spinel, but just to give you an example, the spectra will be different. So having a database, this is the most important, you need a database. Having a database, you can easily separate natural or synthetic. In some cases, it's not always the same story, but for instance, a spinel you can identify with this type of equipment. FTIR means is the infrared, Fourier transform IR, infrared. It's the name of the machine because it is the name of the analysis process behind the test. For instance, a FTIR spectrum. So yes, these advanced machines can help identifying the material or identifying treatments. In this case, we have an emerald. We have tested the stone. It's an emerald and it's a natural emerald. Is it enhanced with oil or with resin or whatever it is? I can have an idea on the microscope, I can see, but the infrared spectrometer can show me if the stone is untreated, if the stone is being oiled, also how much it is oiled, and or if the stone is treated with, let's say, optical artificial resin. It's a kind of resin. This is very important because the majority of the times you have stones medium low quality, but when you get that stone that is top quality, it's important to say the stone is oiled or not. Some stones are clean, but you want to make sure that the stone is not being oiled, because no oil on the certificate makes difference of money, a lot of money. So again, microscope or experience or whatever you want is the maybe 90% of the work, but there is the little bit of help, which is actually a very big help from technology.
You want to explain what exactly is oiling?
What is oiling? Okay. We will go to the treatments after this. Can we do that? Okay. Or with another type of spectrometer, again, talking about the origin. People want to know the origin of the stones. In some cases, tourmalines, blue tourmalines, they want to know if it's a Paraíba or not, if it's containing copper or not. I need a test like that to determine if the peak of the copper is there or not. And from there, I mean, the name Paraíba or not. Okay. As you know very well, these are more or less what you will find in the trade, in jewelry or loose stones, or we have basically rubies, sapphires, fancy color sapphires. Fancy color means any color which is different from blue and red. So yellow sapphires, pink sapphires, they belong to the, let's say, group, or anyway, the species of corundum. Then we have beryls. We have emeralds, aquamarine, morganite, golden beryl, which is called heliodor. Tourmalines, okay, tourmalines have so many colors, and we normally call it with the name of the color, except red tourmaline, which is called rubellite, or blue tourmaline, that type of blue, which is called indigolite, or some other type of blue, which is called Paraíba tourmaline. Garnets, spessartite, grossularite, andradite, and the varieties of tsavorite, demantoid. Spinels, they have no, let's say they have no varieties apart from the color, red spinel, blue spinel. Zoisite, the most famous is the tanzanite, but there is other colors of zoisites. Quartz, citrine, amethyst, topaz in different colors. So corundums, they are double refractive. The hardness is 9. That's why rubies, sapphires, corundums in general are some of the most common gemstones, because at the end, the hardness is really one of the most important properties of the stone. Enhancement treatments, yes, a lot. Whatever they can do, they do it. Synthetics also. They do thermal treatment. They do diffusion, surface diffusion. They do, let's say, the normal diffusion and the beryllium diffusion. They do clarity treatment, which is the glass filling. They do color and clarity treatment, which is, have you seen any of this type of? The color and clarity treatment is the cobalt glass filling. So the regular glass filling is colorless. They use it on rubies. But they can make a white sapphire, they make it blue because they use a kind of blue glass. Okay, so you will see a blue stone which is color treated, plus it is glass filled because the glass is blue.
They can't use laser drilling on that.
Sorry?
They can't use laser drilling.
I have never. Why should they use laser drilling?
White sapphire. Instead of treatment.
Okay, what do you do with laser drilling?
They remove the treatment. Or they do the inside. I mean, they minimize it or they vanish it.
No. They use it in diamonds. The laser drilling they can use in diamonds. But in color stones, first of all,
Especially white sapphire.
I've never seen a white sapphire with laser drilling, honestly. Again, they can do a thermal process, a thermal treatment, or I have seen white sapphires with glass filling. But laser treatment on color stones, the problem, there are too many inclusions, too many problems with the stone itself. I'm sure most probably the stone will break. The laser treatment is not an option for gemstones in general.
So the cobalt treatment is glass filling and diffused laser?
Not diffused. You have to imagine glass filling is colorless glass. Okay, cobalt blue glass filling is a glass that it's been colored by cobalt, which gives a blue color. So they are basically using blue glass.
What's the glass filling?
Glass filling is the same process as oiling the emeralds, but much more. So you have a stone which, if you see it on the floor, you kick it. They take that, they in some vacuum machine, they make absorb liquid glass. Okay, this way the stone becomes transparent or more transparent. Okay, so you have a ruby because it is a ruby, but it is that opaque, you know, that kind of opaque material which is worth 1 cent a gram. You do the treatment and then you can sell it $10 per carat.
But 25%.
It's business.
So in the vacuum, they take out the glass.
No, they put
They
in,
put glass.
yes,
So this thing absorbs glass.
because it's full of cracks. So what happens is,
It's opaque also.
it is opaque because it's full of inclusions and fractures. So the process is a fracture filling with lead glass.
The glass is what, the liquid for
Yeah.
the gas filter?
No, no, liquid. Yes. So one of the problems is that when you do ultrasonic or when you do some chemical bath, it can't, the glass comes out or the glass breaks, so you are damaging a treated stone. And you need to be careful because your customer will complain with you because the stone now looks different. So you have to test before treating, before working on the stone, because if you damage the stone, then he will tell you, no, the stone was a good ruby and you need to buy a good ruby.
But I think now they have some kind of glass fitting you can use it.
Yeah, probably they are improving that technology. Maybe there is a kind of sealing, you know, to protect the fractures.
So this is, and the oiling of emeralds is the same process?
Yes, the same process in the sense that you are going to fill fractures. When you have a fracture, you see the fracture because there is air inside. Story of refractive index, different refractive index between air and stone. So the fracture shows like a mirror, it reflects. To avoid that, you need to put something in between as close as possible to the stone, emerald or ruby. So you are hiding the fracture, okay? With emeralds, you need to use something which has a refractive index close to 1.57, which is, yeah. If you use higher, it shows. If you use too less, it shows. So they use normally oil. Oil means like cedar oil or some natural oil, but that's not too durable, not too stable. You know, it gets old, it gets yellowish, it dries up. So mostly now they use artificial resin. One of these is the opticon. No, glue is different. If you glue the stone because it's broken, that's another story. We are talking about only clarity enhancement, clarity treatment. So opticon would be more stable and does the same work. It will hide the fractures. So the stone looks transparent, but when you look with a microscope or with a loupe, you will see something.
These are easy to do, they're cheap processes? So expensive?
Yeah, no. This is not anything really complicated. It's a vacuum. It's a small vacuum pump because you need to suck the air out of the cracks. Once there is vacuum in the cracks, you inject the oil and it will be sucked in. So it's not a big technology. I mean, they sell the machine, you can buy it yourself. Huh? You buy the machine, you buy the oil, you treat your stones yourself.
They use it on the rough.
Huh?
They use it on the rough.
They use it on the rough when they need to sell the rough. And then after they sell, then the guy has to treat again. Because after cutting, you need to treat again. Because some cracks are not reaching the surface, so they will not be oiled. Or when you cut the stone, the oil is coming out, so Yeah, they treat the rough, but mostly they treat the polished stones.
So, and what emerald, if you touch it, you cannot
No,
feel it?
no, no.
It's polished in the end, so definitely it's not gonna.
Plus, it's not that you dip in oil and in rough, yes. When you buy rough from certain people, it's oily, it's been oiled. But polished stones, again, it's a very little amount of oiling, and that's why now they go with the resins. They are more stable, they will last. The problem with oil was that it was coming out. Some stories, people traveling on a plane, difference of pressure, and the oil comes out. And then the stone, you see, oh, now there is a crack. There was no crack before, because it becomes visible. For ruby, it is the same principle, but because ruby has a refractive index much higher, then you cannot use the same material. You need to use a kind of glass which contains lead, which has a very high refractive index. And yeah, that's how you have to. Huh? Well, more durable now because they are improving, but you need to go close to the refractive index of that stone. So, enhancements, treatments in terms of color enhancement. We said before they start from white sapphires, they make it blue. They make it blue with the traditional thermal process. They know how to do it. Again, this is there is no books about that. It's the experience of the guy, and they know which stones they have to treat. Other stones they will not react. They will not change the color. Sometimes they might even lose the color. So it's not an easy job. Then we have diffusion treatment. Diffusion treatment is a thermal process plus some chemical that will diffuse, penetrate a very thin layer of the stone. The regular blue diffused sapphires are treated with titanium. Okay, so you do a thermal process, somehow you add titanium, it will go in, titanium will react and produce the blue. Then you have a blue sapphire. Or beryllium diffusion, which was a big issue a few years ago, very big problem, because nobody knew what they were doing. So you would have all these orange, yellow, red sapphires, which were treated with beryllium diffusion. So you diffuse not titanium, but you diffuse beryllium, which will provoke this change of color.
Is this permanent change?
Yes, yes, yes. So we said color treatment, we said clarity treatment. Synthetics, a lot. They can make synthetic sapphires any color. This is another group of very common gemstones. Aquamarine, morganite, emerald, heliodor. Okay, it's a kind of yellow kind of beryl. Hardness is 7.5 approx, so it's a good hardness. Then there is maybe a little bit of problems with emeralds. You know, it's delicate. It's when you work on aquamarine or you work on an emerald, because emerald being much more included normally than aquamarine, it's more easily breakable. Enhancement and treatments, yes, they can thermal enhance green barrels and they make it blue. Or imagine an aquamarine which has a strong green component. With the thermal treatment, they remove the green. These are stable treatments, basically impossible to identify. So let's say if the aquamarine has a blue-green colors, I suppose it's not treated. But if the aquamarine is only blue, light blue, then I cannot say if it's been heated or not. Morganite, it's this kind of pink or orangey pink beryl. Morganite many times, or anyway, in some cases can be irradiated. And irradiation, remember, is often not stable. So the problem with the thermal treatment is not the stability, but the irradiation, yeah, it is. Emerald, and so these are color treatments. Okay, there is basically nothing about clarity in morganite aquamarine. There is enough available rough, very clean, flawless, or very clean, so you don't need to work on the clarity, let's say. Emerald, on the other side, is not color treated, so you will not thermal treat, you will not heat the emeralds to modify the color, but you will work on the clarity, as we said, with oiling or anyway, fracture filling, transparency enhancement. This is what they do. They enhance the transparency. Synthetics, yes, they produce synthetic aquamarine. It's not common because it's quite expensive. And always remember, if the material is not convenient, it will not spread in the market. Aquamarine can be very, very affordable. The synthetic aquamarine is quite expensive, so there is not much reason to deal with synthetic aquamarine. By natural, it's not much more expensive. But there is synthetic aquamarine. And synthetic emeralds, of course, with different, we will see also a couple of slides with different process of production. And that sometimes is a little bit a problem. I mean, there is quite a lot of synthetic emeralds in the market. But there is always a way to identify them. Tourmalines, basically any color, even mix of colors in the same crystal. You can have, they grow in long crystals. You can have red, then it goes to orange, then colorless, then it starts green and blue, depending on what was happening at the time of when the crystal was growing. Chemicals available, not available, so all this would change the color. It's quite a common gem. It's 7+ hardness, so it's good durability. There is no specific cleavage or let's say any issue with toughness, tourmaline is quite safe. It comes in big size, it comes in very good clarity. Flawless tourmalines are not difficult, especially in certain colors. Enhancement treatments, there is some thermal process that they apply, and in some cases some irradiation. The problem is sometimes with rubellite to improve the red color, and the copper bearing tourmalines, the so-called Paraíba tourmalines. Paraíba is a place in Brazil. Okay, it's an area where they first found, I don't have a picture anyway, it's a beautiful blue, bright blue tourmalines. But then after that they found similar material in Mozambique, in Nigeria. So similar colors. So they started to say, okay, this is Paraíba tourmaline, even if it's not from Brazil. So what they do, they thermal treat purple tourmalines from these areas, and they change to green, they change to blue, which is much more valid. So yes, in some cases, thermal treatment. Synthetics, no. I mean, I have read that they, as an experiment, they try to produce synthetic tourmalines, but there is no worry about. It's too complicated, honestly, to make it available. So, at least tourmaline, we know it's natural. There is no doubt. Garnets, different colors. Maybe the most common are the dark red, purple colors. Pyrope, almandine, rhodolite. Essonite is orange. Yeah, and some green garnets, which are basically the most valued, the most expensive type of garnets. Good hardness, good durability. Nothing special about the toughness. They have no issue about that. Enhancement treatments, a little bit of thermal enhancement for demantoid. Demantoid is quite rare in the group of garnets. The best quality is from Russia. There is some from Iran. There is some from Madagascar, Namibia. So especially the Russian one, they thermal treat, they heat to improve the green. A beautiful green demantoid costs a lot of money, especially the Russian one. Only this, nothing else. Garnets are normally natural, there is no issue. Synthetics, no, but they have produced some synthetic garnets, colorless, to imitate diamond. It's called GGG, which means something garnet. I will not tell you, it's just a scientific name, or another one. So let's say there is no synthetic garnets. Zoysites, the most famous is the tanzanite, blue, violet, violetish blue. These are the colors. But all those are fancy color zoysites, which are even more expensive than tanzanite. Pink, purple or green, these are much less common and they are more expensive. And they are not treated. Tanzanite, remember that is 90, 98 maybe percent of the times it is thermally enhanced. Tanzanite mostly comes in a brown kind of color. But then we have natural blue crystals from the mining. So there is natural blue tanzanite. Probably it's a natural thermal process due to something deep in that area. Otherwise, they apply a low temperature, which means approx 500 degrees Celsius, and slowly heat the stone and modify the brown into the blue that we all know. Synthetics, no, but there is a synthetic imitation of tanzanite. Basically, there are two imitations of tanzanite. One is glass, but they are really good look. They look very good. They look very, very similar to tanzanite. So one is glass. The other one is a synthetic. It's called forsterite, but okay, it's a kind of peridot. Just to understand. So they produce a synthetic forsterite that has the same colors of tanzanite. And I have seen some of these even in Dubai, not often, but there has been sometimes stones like that. Easily to identify because it's not tanzanite, so already the refractive index will be different. Or the pleochroism, or it's a different material. So it is exactly looking like a tanzanite, but it's not a synthetic tanzanite.
Normally in tanzanite it comes with the gradation AA, single A, triple A. It depends on the enhancement or what?
Okay, that's a trade kind of grading. I don't use any A, double A. Even, the labs, normally they don't use any of that. It only refers to the color, to the how much violet or how much blue, the intensity. Let's say light blue is A, medium blue is double A, intense blue is triple A. So it's not about treatment, because when you buy tanzanite, you assume that it's heated, even if it's not. It's almost not possible to determine if it's heated or not, even though there were some maybe possibility to find out, but basically you don't know if it's heated or not. So it's a commercial kind of grade from the trade. Spinels, it's one of the most valued gemstones for the past, maybe 10 years. Until some time ago, you will not see spinels around. They were not considered at all. Today, you can spend lots of money on certain spinels, especially red. Some red Burmese spinel can go up to $30,000 a carat. Very, very much appreciated in the market. I just put a few pictures. So Burmese, Tanzania, Sri Lanka, Tajikistan. These are, let's say, the biggest producers of spinels. Very good hardness. That's why it's a very good stone. Enhancement treatments, a little bit of thermal enhancement, but it proved that it basically doesn't change anything. They have tried with some red mostly, but they realized that it's not even worth to try the heat process because it will not make a difference. Or okay, maybe once in a while you can get a little improvement, but so spinels we can basically say they are not treated. Synthetics, yes, there is synthetic spinels. Mostly you will find the light blue color spinels, because they use it to imitate aquamarine. So you will see a blue spinel that looks like an aquamarine. Those are synthetic. Not a big issue to identify. They have a different refractive index, even though they are the same material as the natural, and some other characteristic which is quite easy to identify. Quartz. Okay, quartz is very common. There is tons of quartz. Colorless, amethyst, citrine. It's not expensive. It is enhancement, yes. They do thermal process. From citrine they get amethyst, from amethyst they get citrine, or they get green quartz, or kind of yellow, kind of golden color. Synthetics, yes. There is a lot, and they are very difficult to identify. Means very difficult. Visually, most of the time, these stones are clean, are flawless. If you're lucky that you find some specific inclusion, then you can say it's a synthetic quartz. Otherwise, you will need one of those special machines with the infrared. You might see a peak, a special peak, which will indicate synthetic. But again, sometimes it's not even worth to spend money on the testing, because you're still talking about $2 a carat. So, but there is a lot. There is a lot.
Why would somebody make a synthetic?
Because this is a stone that is very common in jewelry, if you think about it. And it's always calibrate size, same color, so you need a consistent amount of stones available. With natural, you don't have this, because natural citrine sometimes is more orangey, more yellowish, color zoning, the same for the amethyst. So when they have to produce cheap jewelry, maybe even silver jewelry, and they need to make thousands of pieces, they cannot go through a selection process. They just make, it's like, yeah, like a big piece, like a big, yes. Anyway, I have a picture. And it's all the same color, all the same, they just cut, probably in China, everything, same size, same color. So, yeah. Topaz, very good hardness, but there is a problem with the toughness. Topaz can break, can split. Not easily, but can. like quartz, there's no problem. There is no cleavage. Enhancement treatments, yes. We said, okay, blue topaz comes natural, but it's a very light blue. It's like aquamarine. But in some cases, it is not stable. It might lose the color. Plus, there is not much available. So they introduced the treatment, irradiation plus annealing, which means thermal process. And you see there is tons of blue topaz in the tray. Otherwise, the more expensive ones, the most appreciated, which are the orange or red or pink, we can have thermal process for these colors. Synthetics, no. There is no synthetic topaz. So, okay, so these are the synthetic, the methods, the process to produce synthetic gems, synthetic stones. The most common, the oldest, the cheapest is the Verneuil method. This is more clear. Anyway, it's basically you introduce the aluminium powder, because corundum is made of aluminium and oxygen. You introduce in this kind of, huh? Yeah. It goes through the funnel. Okay. There is a flame, all the system. It melts, and it crystallizes at the bottom, and slowly it grows. This is what they make. Okay. This is all synthetic. Pink sapphires, ruby, blue sapphires, or any color. It's very cheap as it's an artificial product. Identification, we can see gas bubbles, the curved lines, because it will grow in layers. Curved lines will never be a natural stone. In nature, they have angles, they are not curved. So this is a quite easy synthetic to identify. Flax growing is already much more complex. With this method, they produce emeralds. So you have, again, a solution, a mix with chemicals, water, and slowly the crystal starts form and grow. And we have, that's a flax grown emerald on the left. And these are, let's say, typical inclusions to identify a synthetic emerald. Sometimes we even have small crystals of platinum, because the system is the emeralds are growing inside a platinum kind of container. So part of the platinum goes into the process. No, they just deposit slowly. Emerald starts forming and grows.
That's the main ingredient.
Sorry. What's the main ingredient in the flax? The recipe is always a secret, but they need to put aluminium, beryllium, because this is the elements of emerald. Emerald is beryllium, aluminium, silicium, chromium, vanadium, all that what they need to grow emeralds. The rest of the mix, it's a little bit of a secret, but
So this kind of illusions will come only in rough synthetic, right?
no, this is rough, but then they cut and polish.
Yeah, but after polish, this kind of illusion will be.
Yes, yeah. The way they grow, I mean, it's there.
It's in the materials.
Yes.
So is there a possibility that the same, the whole thing would have different colors and different properties?
You can have a color zoning, yes, because anyway,
It's not that the whole lump will have the same color.
no, you might have color zoning, yes, why not?
It's called Byron.
I'm not sure if Byron is flux or hydrothermal. I think Byron is hydrothermal, which is another process. As you see on the right, you grow big single crystals. This is compared to the natural. So you would have amethyst, natural, white quartz, natural, and then synthetic amethyst, synthetic.
But they should use seed from the same.
Yes, in this process they use a seed. So there is you see in the middle, there is a line that's like a thin layer of synthetic quartz. They put it in this, again, solution, and the quartz will grow. So you can see you have big pieces of amethyst, citrine, very consistent colors, and big quantity. So yeah, this is what you get. And emeralds.
And also like
Nanocrystals are
green
nano, means micro.
the same process.
I'm not sure. It's a kind of deposition process. So even the nanocrystals are probably a similar process that will deposit on something and create a layer. So as we said before, okay, color enhancement, clarity enhancement, treatment. Okay, now we are asking me to basically stop this part and switch to the synthetic diamonds issue. What do you say? There was a little bit of, okay, cobalt glass. Okay. Just a couple of pictures. So cobalt blue. We said cobalt blue. This is what it looks like. Lead glass filling on a ruby. So you can see blue stuff inside the stone. Okay. Thermal treatment, beryllium treatment, normal treatment, origin and inclusions. Okay. So, the first idea of this meeting was to talk about color stones. As you can see, it took us more than 2 hours and we are not finished. And then I was planning to have another day and do, this long story about synthetic diamonds, identifications. For